We're going to talk about variables a little bit more, specifically type of variables called global variables. They are used a lot, so you need to know what they are. And in small programs, maybe they're okay. Generally, they're dangerous, they're risky, but you certainly need to know what they are, so let's explain them. So, so generally, regular variables, they're declared inside a function, and they only exist inside that function. So, not ignoring the picture that I have up there, think about in the last lecture, you have a function called foo, and inside that function called foo, you declare a variable int I. Now that int I, that I is alive when you're executing foo, only within foo. So its scope is limited to the execution of the function where it is defined. So what that means is if you have like a main function which calls foo, the main doesn't see I. I is, since you defined I inside foo, I is only visible inside foo, and the main can't see it. Okay. So that's normal variables, and they call those local variables, right? Because this variable, basically a variable scope, it exists locally. Only its scope is bound by the function in which it's defined. So it's a local variable. So if I say int I inside my function foo, then that I only exists inside foo. And if I have another function called bar or something like that, and I say int x, that x only exists inside bar, and so on. So those are local variables, the standard variables. Now you can also have global variables. A global variable is basically a variable where more than one function can see that variable. Okay, can see the same. They share a copy of the same variable. So what I'm doing here is, so if you look at the top, int global I. So I've defined some variable called global I, and it's an I variable which is global. I want everybody to see it. So I declare it int global I. Note that in order to make a variable global, first thing you've got to do is declare it outside of any function, which is what I've done, right? I could have 10 functions. I'm only showing foo, but I could have 10 functions, but I declare this global variable outside of any function. Because if you declare it inside a function, it becomes local to that function. So I declare it outside. Now, in addition, what you have to do in order for this variable to be globally be seen by other functions, every function where you want this variable to be seen, to be used, you have to declare it as an extern. Okay, so look at that foo, right? It says extern int global I. So it looks like I'm redeclaring the same variable, right? But notice I put that extern in front of it, which means it's an external variable. So that means that this is going to be global, right? So if in my foo, if at the top of it I say extern int global I, then anytime I refer to global I inside my foo, I'm referring to the one global I that everybody sees, okay? So those are the two things you have to do to make a global variable. First, define the variable outside of any function. Then inside every function where you want to use that global variable, you have to declare it as an extern int or extern float, whatever type it is, give you the variable name. Now, that second thing about declaring it as an extern variable, that is not strictly always true. And in fact, in the Arduino sketches that we're going to see, they don't adhere to that, right? So the one thing you have to do is declare the variable outside of any other function. But that extern, you don't have to do that. As long as you declare this global variable outside of the scope of any other function, you declare it at the top of your file, and you're using only one C file, then you don't have to do the extern into global I. If you just refer to global I inside your foo, it will know that you mean the global one. But that only works if foo is in the same file, and foo is defined after the global I is declared. Okay? So in our Arduino sketches, you'll see where they'll, like right at the top of the sketch, they'll define some external variable int x or something like that. And then inside all these functions, they'll use x, right? But they won't extern it, and that'll work. Okay? Now, the extern way is the proper way to do it. And if you have a big program, which we're not going to probably get to programs this big and complicated in this class, but if you have a big program, you've got multiple C files, multiple C++ files, whatever they are, and you want to have a global variable that spans all these different files, then you have to use the extern. Otherwise, one file won't see it. So that's a global variable. So global variables can be dangerous in the sense that the program is less compartmentalized. So they're sharing variables. So what that means is if two different functions share the same variable, then one function can alter and mess up another function. So in this case, we see foo and we see bar. So foo writes to global I, global I equals a plus b, whatever it is. And then bar uses global I to assign x, right? Now, if somehow foo does something wrong, so foo is written incorrectly, say it has a bug. So it writes to global I, but it writes the wrong value to global I. Then that bug is not just contained inside foo. That bug now spreads to bar, right? Because now not only does foo do something wrong, but now bar is forced to do something wrong because bar is getting the wrong data from foo. So it's just another connection between functions. And it's not an obvious connection between functions. So that's another bad problem, because one way to connect functions, to trade data between functions, is if one function calls another function, it passes the data in the form of an argument. Okay? And that's a nice narrow interface, meaning this is the pipeline of information. But globals are these information pipelines between functions that are not obvious to the programmer. So it's hard to necessarily remember all the global interactions. So these type of things are more difficult to see. There are connections between functions that are more difficult to see for a programmer. So it makes debugging harder, because when the problem happens, it's hard to remember, oh, wait a minute, that's right. Foo is passing data to bar through this global, right? So if foo went wrong, that could have messed up bar. It's just another consideration you have to worry about when you're doing debugging. So debugging can become harder, and the code is less modular because of global variables. So generally, you try to avoid using global variables, but especially in these Arduino sketches, they're so short, people use them anyway. And they're so small, maybe it doesn't matter at that scale. It's sort of a bad programming practice to get into, though. But I'll tell you, I see it a lot in Arduino sketches. Thank you.